Hello learners, I welcome you all to this session on median. Basically we will talk about computation of median. Before that, let us recapitulate the previous session, right. So, in the previous session we have discussed arithmetic mean, what is arithmetic mean and what is the application of arithmetic mean and how the arithmetic mean is computed, right. So, in this session we will discuss why to use median, what is median and how to compute median, right. Since if you recollect the lectures, we were talking of measures of central tendency and we saw that the averages may be of two types. One is arithmetic averages and the other is positional averages. So, arithmetic mean was arithmetic average, whereas when we are talking of median, it is positional average. So, now the question comes, so if this device, this tool also tells, right, this measure also tells the central value of data, then why to use median? Why not we can do away with mean, isn't it? So, let us see why do we use median. While analyzing data to comment upon the expected result, we find summary statistics, we have already discussed that. We find mean, median and mode, and mean, median and mode, they are the single value that represents the whole data set. That is also we have discussed in the previous sessions, and we have seen that mean is the most commonly used statistics, but it should not always be used, right. Why? Why can't we use mean all the time? So, to understand it, let us understand it with the help of an example or illustration, right. Suppose you want to know the average wage of a daily wager in a particular region, and you have got the observations of data of daily wages of 6 days of a particular worker, which is maybe some day he is getting rupees 450, some other day 450, the other day 500, the other day rupees 300, but for some reasons for the rest 2 days the worker is getting rupees 5 and rupees 8 only. So, if you see this data set, if you see this observation, you can see two extreme values, rupees 5 and rupees 8, and we have already discussed again that the extreme values in statistics we call it as outliers. So, what is the impact of outlier? In this example, if you see, if you want to take out the average of the daily wages of a particular labor or a particular worker, the average will come out to rupees 285.5. How do we calculate average? We have already discussed, like we will add up all the values, all the numbers of the variable, rupees 450, rupees 450 again, rupees 500, rupees 300, rupees 5 and rupees 8, which comes to 1713, and then we will divide it with the number of observations. In this case it is 6 days. So, 1713 divided by 6 comes to rupees 285.5. Now, the arithmetic average which is coming, don't you think it is it is not representing the best scenario? If we remove the outlier, as I said, for some reasons for 2 particular days the daily wage of the worker has reduced down significantly to rupees 5 and to rupees 8. So, these outliers, they are pulling down the average. So, you will not get the near close picture of the average wage of a particular worker. So, in this kind of situation it is always better to use positional average rather than using arithmetic average, and positional average is what? Positional average is median. There are other partition values also, which is not the point of discussion in this particular session. So, in this session we are only focusing on median. Unlike arithmetic mean, median is based on the position of a given observation in a series arranged in ascending or descending order. Since it is based on the position of given observation, that is why it is called as positional average. Median of a given series is the value of the variable that divides the series into 2 equal parts. So, median is what? It is the most central point of a series where half of the items lie above this value and the remaining half lie below this value if you arrange the data, the observation vertically, right. If you arrange it horizontally, you can say that half the items lie at the right hand side and half the item lies in the left hand side of the observation. And in statistics, the median is usually denoted by MD. You can also denote it as M or MD. Now, let us talk of computation of median. The data can be ungrouped data and the group data also. What is grouped and ungrouped data we have already discussed. So, now let us see how do we compute median when the data is ungrouped and how do we compute median when the data is grouped. Even when the data is ungrouped, how do we compute median when n is odd number, or how do we compute median when n is even number, right? Let us move forward. We are talking of median for ungrouped data. In order to understand how to compute median for ungrouped data, let us see what are the various steps that are to be followed while computing median for ungrouped data. Suppose we have to calculate median for ungrouped data and the n is odd, then in that case, first of all, we need to arrange the observations in ascending or descending order. Whatever observations are there, arrange it in ascending or descending order. Then we have to apply the formula n plus 1 upon 2th item. So, the value corresponding to n plus 1 upon 2th item is denoted as median. Let us now understand it with the help of an example to make it more clear to you, right. Say for example, the observations of a particular variable is 6, 7, 4, 8, 11, 5, 3, 9 and 10. If you see, the number of observations in this particular example is 9 and 9 is odd number, right. So, in this case what we have to do, we have to arrange the data in ascending or descending order. You can arrange it in ascending order or you can arrange it in descending order also, right. So, you have to arrange it and then we need to find out n plus 1 upon 2th item. In this case n is 9. So, n plus 1 becomes 10, 10 by 2, that means how much? 5th item. So, the value corresponding to the 5th item would be median. In this case, when we arrange the data, say for example in ascending order, so it comes like 3, 4, 5, 6, 7, 8, 9, 10, 11. So, we have arranged it. So, 5th value in this case is 7th. So, for this example, in this example you can see that the median is 7, right. Now, let us talk about median when the ungrouped data is even. Steps to compute median in ungrouped data when n is even. Same, first of all we need to arrange the observations in ascending or descending order. Then we have to apply the formula n plus 1 upon 2th item. But here in this case, since the observation the n is even, the value that will come, the value of what? N plus 1 upon 2th item will come in fraction. So, now you cannot, like in fraction you cannot exactly locate the median, the position of it. So, in this case what do? We need to find out the average of the corresponding values of the fraction. Again, let us try to understand it with the help of an example, right. Let us move. Say for example, there are certain values and the values of the variable is 8, 11, 13, 16, 20, 32, 41, 36. These are the values. So, in this series if you see, the total number of observations are 8 only and 8 means an even number. What do? The formula is n plus 1 upon 2th item. So, 8 plus 1 upon 2th item and this will come to 4.5th item. In the earlier case when the number of observations were odd, you could exactly locate the position of the median, but in this case since the value is coming in fractions, so you can try to see that there is no item with the serial number 4.5. So, what do? We need to take the average of the items 4th and 5th as medians. That means we have to see the corresponding value of the 4th item and then the corresponding value of the 5th item and take out the average of value of 4th item and value of 5th item, and that will become your median. So, in this case if you see, the 4th item is 16 and the 5th item is, the value of 5th item is 20. So, taking out the average 16 plus 20 upon 2, which comes to 36, 36 divided by 2 is 18. So, median is 18, right? Got it? Right. Now, we have discussed till now computation of median in ungrouped data, right? Now, discussing the computation of median in discrete series. So, let us see these steps first. First of all, we have to arrange the observation in ascending or descending order along with their respective frequencies, right? We have to be very particular about that. And then we convert the frequency f into cumulative frequencies. How do we do that? We will see that in some point of time when we are talking about the solution. We will try to help with understand this with the help of an example also. And then the third step is to apply the formula of median, that is n plus 1 upon 2th item. Now, locate the value of n plus 1 upon 2th item in the cumulative frequency and determine the value of the variable corresponding to that cumulative frequency. So, the frequency which is coming, the value which is coming will be median value, right. Now, let us try to understand it with the help of an example also. In a class of certain students, say for example, the students of 12th standard, the marks of students in a particular subject is given as follows. 9 students, they have scored 40 marks, 75 students, they have scored 15 marks, 72 students, they have scored 25 marks, 20 students, they have scored 5 marks, 45 students scored 30 marks, 39 students 35 marks, 43 students 10 marks, 6 students 50 marks, 8 students 45 marks and 76 students 20 marks, right. So, this is the observation which is with you, this is the data which is with you. Now, for this data we have to calculate median. So, how do we do that? As we have discussed earlier also, that it is always better to prepare a table when we are trying to compute certain thing in statistics. It is always better because it gives you a kind of ease, right. So, let us prepare a table. As I said in these steps that we have to arrange the data in ascending or descending order, and then we have to write their corresponding frequencies in front of them, and then we try to calculate cumulative frequency. So, we will try to make a table and then try to calculate the median or compute the median. So, your table will come like this. In the first column, you have arranged all the marks in particular subject in this case I have arranged it in ascending order, and then we have to write their corresponding frequencies, their frequencies only. Like there were 20 students who have scored 4 marks. That is likewise we have in the second column we have arranged all the frequencies, and then we try to calculate the cumulative frequency. And how do we calculate cumulative frequency? The above frequency will be added with the below frequency, and the value that comes will be the cumulative frequency. Like in this case, in the first row if you see, there is no other value. So, the cumulative frequency will be 20, but in the second row 20 plus 43, that means values of the column CF plus the next value of column F, 20 plus 43 is coming to 63, and then 63 plus 75 is coming to 138. 138 plus 176 is coming to 214. Likewise, we will calculate cumulative frequency. And one important or one interesting fact you will see is, if you try to find out the summation of f, which is called as n, summation f, that means 20 plus 43 plus 75 plus 76 plus 72 plus 45 plus 39 plus 9 plus 8 plus 6, the value will come to 393. And here in this case, if you see the last row of the cumulative frequency, the value is coming to 393. So, this way you can cross check your cumulative frequency calculation also, right. Now, we have prepared this table, and now we have to calculate median, and to calculate median, what formula do we use? N plus 1 upon 2th item. So, here n is what? 393, summation of f n is 393 plus 1 upon 2th item. So, 394 upon 2th item, that comes to 197th item, and if you try to see 197th item in the cumulative frequency, so you will see that it falls in 214, because if you take the above one 138, it will be less, right. So, it will be 214. So, the corresponding value of 214, that is 20, will be median in this case. right? I hope you have understood this. Shall we move forward? All right, let us move forward. Now, we will try to understand how to compute median for continuous series. In the case of frequency distribution of continuous series, exact values of various items are not known. Therefore, the value of a particular item cannot be found. So, in this case, we need to find out the value which has half the items below or above it. Thus, in order to locate median class, n upon 2th item is taken in this case and not n plus 1 upon 2th item. I repeat, in continuous series what we are doing, in order to locate median class, we have to apply the formula n upon 2th item and not n plus 1 upon 2th item, right. And the rest of the procedure, if you see, it is same as it was in the discrete series. Having located the median class, the exact value of the variable can be interpolated from the median class by applying the formula. So, let us quickly see or understand it with the help of an example. And before example, I would try to show you the formula also. See, in continuous series, the class may be also the less than and the more than. So, if it is the less than method, the formula would be median is equals to lower limit L plus n upon 2 minus c upon f into I. L is lower limit of the class plus n upon 2 minus c upon f into I, right, where c is cumulative frequency of a class preceding the median class, f is simple frequency of the median class, I is the length of class interval of the median class, and the length of this class interval is upper limit minus lower limit, and n upon 2 is the half of the number of observation, which can also be denoted as m. You can represent it as you like it, all right. There can also be a data which shows more than, then in this case the formula would be median is equals to upper limit plus n upon 2 minus c upon f into I, or in this case everything is same other than the L. Here we are talking of u, that is upper limit of the median class. So, if we see it with the help of an example, say for example, if I say monthly income of 50 families is below 100, 500 families is from 100 to 200, 555 families from 200 to 300, 100 families from 300 to 500, 3 families from 500 to 800 and 2 families 800 and above. In this particular example, if you see, the class intervals are unequal and the data is open ended. So, this does not affect the calculation of the median, and the length of class interval in the formula corresponds only to the median class. So, we are not trying to convert this unequal class intervals into equal class intervals. Again, we will try to formulate a table. We write the monthly income, the class intervals of monthly income in the first column, then the number of families, and then we try to calculate the cumulative frequency. We have already seen how do we do that. So, as I said, in continuous series, median is n upon 2th item below it, which mean if you try to take the summation of f, it comes to 1210, divided it by 2 comes the value 605, that means 605th items below it. Therefore, the median lies in this class interval 200 to 300. So, once you locate the class interval, your median class, then we have to apply this formula, median is equals to lower limit L plus n upon 2 minus c upon f into I. In this case, the lower limit was 200 to 300. So, L is 200 and u is 300, L is lower limit. C is equals to 550, F is equals to 555, I is equals to 100 and N is equals to 1210. In this case, the median would be 200 plus 605 minus 550 upon 555, and the value comes as 209.91. So, this shall be the monthly income of the families. So, with the help of certain formulas that we have tried to understand how to compute median, maybe in the next session we will talk of some other examples or maybe mode. Till then, keep learning.